So, anybody go to this event where we did the rooftop? Yeah, that was fun. Yeah, a couple. All right. That was definitely a fun event at the end of summer this last year. So, Rocky Mountain Angular, we are a meetup group. We're actually now considered a super group for some reason. I think it's the number of meetups that we've done over the years and the size of the meetup. We have a website, rmangular.org. You can follow us on Twitter. I highly recommend getting on Twitter if you're not on there already following us. There's a lot of special offers, chances to get tickets before anyone else gets them, chances to get tickets at discounts. So there's lots of things that you can find out through Rocky Mountain Angular. We have a YouTube channel, so you can go out there and you can pretty much see every single presentation that we've done with Rocky Mountain Angular in the last 3.5 years. So all the way back, you're doing some Angular JS, man. There's some great testing tutorials. I wouldn't say great. I did them. It's like one of the first talks I did. It wasn't really great. And then we also have a Slack channel. So there's Angular Colorado. Who's on the Angular Colorado Slack channel? Few? All right. So this is a great opportunity if you're working in Angular and you want to be able to reach out to other local devs and get answers or ask questions and stuff. Like, great opportunity there. All right, so really quick, we're going to talk about the code of conduct. Just basically treat each other as civil human beings, and let's make this an environment of learning. And if you have an issue, you can send an email. There's also a phone number. If you forget any of that, the code of conduct is over here on this banner as well, and so that information is there. Or just grab one of us, either myself, Brian, if you'd stand up real quick. Or Jessica over here, and just grab one of us and report it. And so we take it very seriously. Upcoming meetups. So we have a meetup coming up on the 7th? No, I'm like, that's today. That's today. So it's actually the 19th. And it's downtown at Crown Peak. And we're going to have 2 different presenters. We should have that announced. Actually, the meetup is announced, but the talks have not been announced. We should have those tomorrow or Monday and get those announced. So it's a new location. It's right downtown, right off light rail, super easy to get to. So and then we've got Angular Denver coming up. So Angular Denver is August 1st and 2nd. There will be workshops on July 30th and 31st to boot. And you might be able to see Joe Eames do a workshop. I don't know. Well, in discussions there. But so we this is actually going to be our second year doing Angular Denver. And last year it was a 1-day event, and this year we're going to expand it to a 2-day event. We're expecting about 300 people for attendees. Last year we did sell out. And we had people come in from as far out as, like, I believe, Chicago and New York. So sponsors. So Brie Bug. So I'm the CEO and founder of Brie Bug. We're an Angular consultancy here in Denver. We do architecture reviews. We do custom training, consulting, and staff augmentation. So we actually have 6 Angular GDEs on staff, and we help companies out from all the way down to little small mom and pop companies all the way up to the big companies like FedEx, Chipotle, MapQuest, Verizon, stuff like that. So, and we also, Joe is the CEO of Thankster, and so he is also one of our sponsors tonight. So, I already covered that slide, so we're good there. Let's see here. On May 1st through the 3rd, we have NGconf. Who's going to NGconf this year? Got a few? Yeah. Okay. So if you haven't considered going to NGconf yet, I highly recommend it. It's the world's, is it the largest? And it's the first, right? Angular conference. So Joe is one of the conference organizers. It's one of my favorite events to go to every single year. Myself, Brian Love, and Kevin Schuhart are all going to be there speaking. And so be a great opportunity to see us speak, as well as see the Google team and find out what's going on with Angular and what's going on in the community. Plus tons of fun events at night. It's really a great time. And so with that, I want to bring up Brian Love to do the news.
Next slide.
Wow.
All right, guys, thanks for coming out. If you're new, we do this every month where I kind of give you guys a quick 5 5-10 minute what's been happening in the Angular community. If you have been paying attention, we've got a couple of things that have been coming out, and I'll just kind of go through this list. Jesse already mentioned NGconf, so I won't mention that, but real quick, tickets are still on sale. Joe, how much are they? The early bird prices are over now, right? Isn't it 13?
Yeah, early bird's over, so 1,300, and then it goes up to 1,500 on March 1st.
On March 1st. So, yeah. So if you're thinking about going, talk to your employer or whatever you need to do to make that happen. We'd love to see everybody there. So the first thing I'm going to let you guys know about is Angular Bazel. Bazel is a build tool that is kind of a highly optimized build tool that's coming and will eventually be shipping in Angular. So this isn't necessarily like a replacement for Webpack. It's like a bundler. This is a build tool that's going to allow us to do really fast incremental builds for large projects. I don't know if you've got a large Angular enterprise application where maybe your prod build takes something like a minute or 2 minutes to build, right? This is going to help to minimize that. And so there's some really great optimizations in that. It's still in, like, I don't even say beta release yet, but you can play with it, and you can npm install it. They've got some schematics, so make it real easy right now. You go ahead and build an Angular project using Bazel build. We also had Angular 7.2 came out in the last month or so. With that, we had some pretty big improvements to the router, along with some bug fixes and stuff. So check that out if you're not on 7.2 yet. Angular 8.0 beta just got published, I think, about 2 weeks ago. It's definitely not ready to play with, so don't even bother touching it. But we should be seeing Angular 8, major release from the Angular team coming out sometime this spring. So probably April-ish, right? So you can start kind of looking at that and planning for that in terms of like your outlook, in terms of keeping up with Angular updates. NGRX 7.0 was also released recently in the last couple of weeks. Some great improvements there. Not a lot of break-in changes, if I recall, if not any. I don't know if there were any break-in changes in 7. But they added a couple of additional like lifecycle things for NGRX and some additional like projector style stuff. So definitely check that out. Brandon Roberts just wrote a blog article on it that kind of details all the changes in there. So certainly check that out. And then NX has been updated with schematics for Nest.js, which is pretty cool. So that way you can have in a single monorepo, have Nest.js, which is kind of like an Express. If you've used Node, it's like an Express backend with some really nice syntactic sugar. So it's very familiar for us as Angular developers using TypeScript and things like decorators. And that got all updated with NX and their latest release. So check that out if you're using NX and you're thinking about doing a monorepo with your front end Angular and your back end in Nest.js. That's all I got. Cool.
All right, excellent.
Thanks, guys.
Thank you. All right. That's the end of the slide deck. All right, so I'd like to go ahead and introduce our speaker tonight. Your speaker tonight is Joe Eames. He is a Viking at heart, I hear. But by day, he's a mild-mannered author on Pluralsight. I think, Joe, you just hit 1 million hours? Okay, I just hit recently, I had a success to share too. I got to 1 million seconds of watched videos. Maybe it might have been nanoseconds, I'm not sure. But no, he just hit 1 million hours on Pluralsight for his videos being watched. A lot of people have learned Angular from Joe, and proud to have him here tonight. So he's also an organizer of NGconf. He is a Google developer expert in Angular, and he gives a lot of talks and workshops. He gave a workshop here today. So he's been at this all day today, and he loves all things web. So with that, please give a big warm welcome to Mr. Joe Eames.
Oh, wow.
Wow, we're hot. We're live?
We're live.
Is that live? Is that the music?
Oh, it's fun.
Oh, yeah. Wow.
Can't hear you. All right. Different connection? What? Oh, just HTML. I got a real laptop. Oh, yeah, we're real laptop. Oh, goodness. All right, put that there, right there.
Andrews, will you Am I okay to flip my mic on?
Let's go ahead and turn it on. Let's see what happens. Anybody? Can anybody still hear us?
Just turn this one up just a tad. Sorry.
These are.
All right, talk normal.
Hi, my name is Joe.
I said normal.
Hello. Hello. Hello there. If I was Aaron, I could do a really cool accent. He can do some great stuff.
Hello.
I actually do a pretty decent bad French accent. Oh. How was it? Okay. We are going to talk about unit testing best practices tonight. Everybody hear me okay? Levels seem to be okay, Jessica? Yes. All right, awesome. So, as Jesse said, my name's Joe. I run Thinkster.io now. I've been doing a lot of teaching for the last 6 years. I've been basically a full-time teacher. But my heart was always in testing. That was actually kind of the reason why I decided in around 08, 09 to switch from being, I think nowadays we kind of call them full-stack developers, but at the time I was really back-end. You know, we did web and we did the front-end, but it was .NET what I did, and ASP, and you know, we built the whole shebang right up front, and JavaScript was something that, if anything, out of the 10 people, we might have one person that could kind of do some JavaScript, right? And man, I wanted to learn more jQuery and get better at JavaScript, but I was really enjoying C#. And we did a lot of engineering practices. We did a lot of pairing and test-driven development and Agile and patterns and that sort of stuff, and I really enjoyed that kind of thing. And then the front end started getting bigger and bigger, and that was, you know, around that time Gmail had come out, and Google had proved that you could actually do some really cool stuff with JavaScript. And I said to myself, you know, I'll bet, as I looked around, I didn't see a lot of people talking about testing and engineering practices, that sort of stuff, and I thought, I would really love to take my experience in that thing and go do front end where there's all kinds of cool stuff going on. I mean, there's constantly new advances coming out. Knockout was just all the hotness, and I thought this would be pretty fun. So I kind of made this conscious decision to switch and become sort of a front-end developer. And so my heart has forever been in unit testing and in testing in general. In, I think, 05, I bought Kent Beck's awesome book on test-driven development by example, and I taught myself to do test-driven development. And then we started practicing at work, and I was super sold and convinced at that point, and I just love doing that stuff. When I discovered Angular, I was actually working on a small contract at Pluralsight, and we were building their HTML5 video player. They wanted to build their video player in HTML5 with the HTML5 video, and we were doing a proof of concept, and that's when we discovered Angular, because it was the only big framework out there that really inherently supported testing. So that was when I got into Angular, and things radically changed for me, but my heart and the core of who I am has always been about testing. So the workshop I did today was about Cypress, which is a testing tool, and I just love all things testing. So I think that testing is interesting because compared to code is kind of one of those things where if you produce really, 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 really bad code, but it is correct, right? It actually produces the desired output, but it's super unmaintainable, you know, really difficult for anybody to understand and grok. You have still created a net positive, right? Right? You've done something positive. You've created a product that now works. Maybe you're the only person in the world that can maintain it. Maybe not even you, but you've done something better. Tests, on the other hand, one of those things where if you read a test that doesn't correctly test something, you have added weight to your project without adding any velocity or anything positive. So you can be not only net negative, but you can be fully 100% negative if you are ineffective in your testing. So that's why I think it's really important to understand good principles of testing and to see them and to look at the wisdom of people who have been testing before and to understand why they say to do certain things certain ways. And I'm talking about not like necessarily somebody like me who's done a lot of testing, but really the pioneers of testing as a craft. Talk about people like the signers of the Agile Manifesto, Kent Beck, and Martin Fowler, and people like that who've really developed a lot of stuff and understanding them, and then people that came along after them. Those giants for whom other people have stood on their shoulders and generated new stuff like Cypress and Selenium and Protractor and Karma and all these really cool tools, but still understanding that there are foundations to what is or is not a good test. And I don't also consider these foundations to be universal 100% of the time, right? These best practices. Because the best practice is simply something that has been found to be a good idea in general over time, right? That doesn't mean it's always a good practice or the best thing to do in any given specific instance. But I think it's important to understand what is a best practice, and when you decide to vary from it, understand why you're varying from it. Don't just do it differently because you want to do it differently. Instead, understand the fundamental principles underneath it, and then decide consciously, we're going to try something different because it looks like it might be better. We know we have really high confidence it's going to be better, or maybe we're just making an experiment, whatever that is. So with that, let's go on. I think we definitely have to talk in general about testing itself before we talk about unit testing best practices. So what is automated testing? When I say testing, I mean automated testing. I'm not talking about manual testing, right, which I have done a fair amount myself. I'm talking about automated testing. We write a program that's going to do our testing for us. Well, this is the testing pyramid we've seen in front of you, and it's very commonly shown. There's a really good chance you've seen this before. The testing pyramid always shows end-to-end at the top, integration in the middle, and unit at the bottom. And there's a lot of reasons why it's depicted this way. The spatial division there, the end-to-end has by far the smallest area of them. Integration has a bigger area, and unit has the largest area, is very purposefully done. That is because generally we write a fairly small number of end-to-end tests compared to our number of integration tests. We write a smaller number of those than we write of our unit tests, and oftentimes, depending on the project, we're talking an order of magnitude of difference. I have found in general that I write about 2 orders of magnitude more unit tests than I write end-to-end tests. That isn't certainly universally true, but and I've been at places where there was no unit tests. It was all end-to-end tests. That was the only thing there were. I've been at places that had no end-to-end tests and only unit tests. But generally, this pattern follows true, is that we write a lot more unit tests than we do end-to-end tests, and more integration tests than we do end-to-end, and more unit than integration. So actually, let's talk a little bit more about each of these pieces. It's good to understand what each of these are, so we'll take a quick minute and define each of these. End-to-end tests are tests where you stand up your entire full system. We're talking front end. I'm mostly going to be talking about web here, but all these principles apply to things that are not web as well. But mostly going to focus on web. So your front end, your server, your data storage. All those are up and they are running, right? Now you might be using a test-specific data storage mechanism. So maybe you've got a test copy of your database, right? But it is still the whole shebang. All the pieces are up and working. And then you somehow automate your front end. So your front end is up and existing, and you hook up some other program to the front end and tell the front end what to do, and you act as if you were a user. So you work through as if it was a user clicking and typing in buttons and navigating to the URLs and that sort of thing. That's an end-to-end test. Then I'm going to skip integration and go down to unit test. So end-to-end test is your whole entire application. A unit test is testing one single unit at a time. And how you define what a unit is can be a little bit subjective and vary a little bit from person to person and from project to project. But in general, most places and most people consider a unit to be a single class or file, depending on the technology, but generally just one. Now, there are plenty of places that consider unit to be a specific class and its closely related classes. That is not uncommon at all, but generally a unit is a single class, right? So with unit testing, before I talk about integration tests, I'm going to back up and talk about the characteristics of end-to-end and unit tests, and then we'll talk about integration tests. So the characteristics of end-to-end tests are that they are very slow. Relatively, they are very slow because you have your entire application up. So a single end-to-end test may take seconds to run. A unit test, on the other hand, is extremely fast. Generally, a unit test takes milliseconds to run, right, in comparison. So that's another reason why this pyramid sort of implies is the amount of time it takes to run these tests, right, where instead of the wide being longer, the wide is faster. So end-to-end tests are slow, unit tests are very fast. End-to-end tests tend to be brittle and flaky, meaning they fairly often cause false positives, right, where they fail, but they aren't failing because anything's actually broken. They're failing because of a limit of the technology. Unit tests rarely do this, right? Generally, unit tests are extremely stable. You can run them 1,000,000 times, and they will always give the same result. Either the code is broken or the code works. End-to-end tests, sometimes I've been at places where when we run and we get our end-to-end test failures, we run it 2 or 3 times, and we only look at the tests that failed all 3 times. The ones that only failed once get filtered out. So those are kind of the characteristics of end-to-end versus unit tests. End-to-end tests tend to be harder to write. Unit tests tend to be easier to write. End-to-end tests tend to be harder to maintain. Unit tests tend to be easier to maintain. End-to-end tests tend to break due to changes in the system more frequently, although oftentimes unit tests will break in very large batches. You make a single change and then you break a large batch of unit tests. So those are some of the characteristics of end-to-end and unit tests. Finally, we have integration in the middle. Integration tests are basically anything that isn't a unit test or isn't an end-to-end test. So it's not the whole entire system, it's a piece of the system. It's not a single unit, it's bigger than that. And depending on the technology, that could be various places, but various ways, but the most common way that I've seen this is you take, in the web, you either take your front end and you have a mock HTTP server that is your API, and so you're testing just the front end against a mocked back-end HTTP server, so it's a lot faster than calling to a real web server that then calls back to a real database. Or vice versa, you take a mock front end and talk to your real back end, usually something like Postman, or there's various other tools where you could just make HTTP calls, make your RESTful calls, and test them. So those are integration tests, and they tend to sit exactly in between them. They are more stable than end-to-end tests, maybe sometimes less stable than unit tests. They're faster than end-to-end tests, but slower than unit tests, et cetera, et cetera. So that's automated testing. Let's talk about the benefits of testing. These are actually just a very small section of the benefits of automated testing. First off, automated testing documents our intentions, right? So when we write an automated test, we have fixed in place a piece of functionality. If that functionality is now fixed in place, we have declared that we want this to work in this specific way, right? That's different than I write the code to work a specific way, because I might put a bug in my code in which the code doesn't work the way that I want it to. But when I write a test around that code, I am saying I want this code to work this way. Right? So that's one of the things. Is it also tends to be a lot easier to read, because it's not the underlying internal code that we're trying to parse through. Instead, it's I hook up to this and I do this and then this should happen, and I do this and then this should happen. So it documents our intentions. The next benefit is it tends to improve our design. This is because generally in order to test you have to have a fair number of attributes. But certainly when I talk about unit testing, we need to have our code fairly loosely coupled. If it's not loosely coupled, then we can't test a single unit at a time. And loose coupling is a good design pattern to follow. And there's various numbers of other reasons for this, but generally testing improves our design. It's worth talking about. There's this sort of theory of testing in that if code is hard to test, it's a code smell, right? So that's another reason why testing improves our design, because as we try to test our code, if we find that it's hard to test our code, we oftentimes change our code to make it easier to test, and that generally improves the design of our code, generally. Another benefit is if we put fewer bugs into production, because we find our bugs before we put them into production. It keeps us from, it reduces the number of regressions. I say no regressions, but that's a little bit too optimistic. It definitely reduces the number of regressions, because now we have code, we've got these tests that fix functionality in place. When we break that functionality, we are told about it in an automated fashion, especially in the situation where I've changed code over here and something way over in the other corner breaks, right? And I didn't realize there was this strange dependency, right? I got a fair number of laughter out there, a fair number of late nights because of things like that, right? So we reduce our number of regressions. Finally, it gives us a safer feeling of refactoring. If I decide I want to change how the code works and refactor, something, I can feel a lot safer if I have a set of unit tests that ultimately get back to a passing state as I'm refactoring. Hopefully they never break, but that's oftentimes not possible. So those are just some of the benefits of testing, and specifically unit testing that we have. So I'm going to talk specifically, like most of this is going to be specific to unit testing, right? I talked a little bit about all kinds of automated testing, but I'm going to talk mostly about unit testing. So here are the two types of unit tests that we write: interaction versus state testing. This can also be called white box versus black box testing, right? So state-based testing is a system where I change the state, and then I make sure that because of the state change, that something has happened that I can tell has caused a change in state. So as an example, I might add an item to a shopping cart. I initially start off with an empty shopping cart. That's my initial state. I add an item to the shopping cart, and now my new state is there is one item in the shopping cart, right? So initial state, change, resulting state. The nice thing about state-based testing is I don't need to understand the internals of how the algorithm works. So if, for example, when I add an item to the shopping cart, it takes this item, it creates an entire duplication of the actual item, and then it adds 5 copies of the item to the shopping cart and then deletes 4 of them. In the end, I have working code, right? The algorithm itself may be highly optimized, it might be poorly optimized, it might be very performant, it might be poorly performant, it might be very maintainable, it might not be maintainable at all, right? But all I know is that things are correct. That allows me to refactor the algorithm to a high degree, and my test simply asserts that things are true. A variation on that is state-based testing, where I am asking an algorithm to return a value, right? So I'm testing my add function. I pass in 2 and 2, and I receive back 4, right? I don't care how 2 and 2 are combined to produce 4. I don't care if there's a big lookup table, two-dimensional lookup table of every possible value of integers, and then the resulting what that would be. That's okay with me because I still get a correct result, right? So that's state-based testing. The other kind of testing is interaction-based testing. And this is the case where, this is called white box testing. We need to actually understand the internals of what's going on to know that the code is correct. Now at first glance, or at first thought, you might think, no, that's stupid. We should never need to know that. We should always do black box testing, which has a lot of benefits, but the reality is you must white box test very often because our systems interact with other systems, or our units interact with other units. As an example, if I add an item to my shopping cart, right, then one of the correct pieces of the algorithm likely is going to be that we persist that change to our data storage. So in addition to calling cart.add or cart.push or array.push if it's just a simple array of items, in addition to that, we might also need to talk to our persistence service and tell that persistence service to save this change off to the server. So we would call cart storage.save or cart storage.update or whatever. We just call some method, right? And that is our algorithm is not correct if we do not call that method, but nothing detectable has changed because we called that method. It simply fired off in the end result. It fires off an HTTP message off to the ether, and I don't want to run my whole system and inspect my database that it added a new item. I just want to know that it did that job correctly. So that's interaction-based testing, where we're calling a method on another class, and we want to know that it called the method on the other class, and then it called the method correctly. For example, if it calls, say it was the method was persistence.addItem, right? We want to know that it only called it once, not twice. We want to know that it called it with the right item. So we need to know not only what method was called, but how many times that method was called. We need to know what parameters that method was called with, and we might need to know that it didn't call any other methods on the persistence object, right? And that's how we can test that the algorithm is correct. So that's interaction testing. And in that case, we assert, rather than that state has changed, we assert that a method was called correctly. So these are the two types of testing. It's very good to understand them. And as much as possible, we prefer state-based testing, which means when we can design our code such that it's more black box, then we have an easier time. We have, one, better factored code, and we have an easier time testing that code. But as it is necessary, we oftentimes will have to interact with other pieces, in which case we have to write interaction-based tests. Here's some examples. I kind of talked through these, right? We call math.add, and we expect the sum to be the correct value. Or with state-based, this is still state-based testing, but this is a cart, right? I call add on the cart, and then I check that the number of items in the cart is now the correct number. Whereas with interaction testing, my particular object I'm testing calls save. So I might call save on my persistence object, and underneath it, it calls the HTTP server's post method, right? So I give it a mock HTTP server or HTTP library, and I assert that post was called. All right, so with that laid out, with that groundwork laid out, let's move into what are actual unit testing best practices. The first one is what I call the AAA structure, well, what many people call the AAA structure, which is we should structure our tests properly. So, in a test, we want to first arrange all of our necessary preconditions and inputs. Next, we want to act on the object or the method under test. Finally, we want to assert that the expected results have occurred. This is State Machine Basics 101. I'm going to put my code in state A. I'm going to cause a state change, and then I'm going to check that state B, or the resulting state, is the state that I expect, right? That ultimately I do get to state B, right? So arrange, act, and assert. So here's an example. I create a cart object. I call add on that cart object, and then I expect that the number of items in that cart object is the correct value. It started off with, ideally here, 0, or as we read this code, it probably starts off with 0, because when we add 1, there should be 1. Right? We shouldn't start off with -1. We shouldn't start off with 4, call add, and end up with 1. Those will be incorrect. So this is how we arrange, act, and assert on our code. Personally, I also like to visually separate out those pieces inside of my test. I find that it has an easier time telling what's going on in the test when I have the arrange here. There's some visual separation, at least one white space, one line of white space, maybe more depending on the size of the test. Then my act goes on in the middle, then a little bit of visual separation, and finally my asserts fall down to the bottom. I don't like them all to run together. Best practice number 2 is to include our tests in CI. This should be fairly obvious, but if we're going to go to the great length of writing tests, then we should have a CI process that runs our tests for us, so that whenever we check in our code, our CI system runs the tests and makes sure that the tests actually pass, because it's very difficult to assume that developers have run all their tests every time before they check in code, and certainly you don't want to be the one that breaks the build, right? So having a gated check-in specifically that doesn't allow the check-in to happen unless the tests all pass, right? Or a system whereby when we check in code, if it breaks the code, that it doesn't actually make its way into anything. We don't have a broken build and hurt other developers, right? Maybe developing on a local branch or something like that. So this is obviously a really good idea to have some kind of a CI system. If you're using GitHub, Circle CI is super nice. It can handle all this for you in very small amounts of time to get set up. And if nothing else, at least all your test suite will be run every time you check in your code. The next best practice in unit testing is to only test the unit, right? Again, this may or may not seem obvious on the surface, but the reality is that oftentimes we end up writing tests that test things that aren't the unit. The technical term for the unit is the system under test, or SUT. We want to make sure that we are only testing our unit. So we do not test more than one unit, and we don't test our framework or third-party code. This is the second bullet point that's actually the more finely tuned, difficult to grasp concept, the one that can come up and you can look at, well, I need to write this test to make sure this works, but the reality is you might be testing your framework or your third-party code. So let's look at this. Here we have a customer object. we initialize that customer object and we pass in a mock discount calculator, right? So then I might expect that my customer, I call it like get discount, to be this 0.35, right? Well, I could easily within this code, because I have this discount calculator going on, right? That's actually where all the real work of the calculating the discount is, right? So I want to make sure that I'm only testing inside my unit what's actually going on in there. Maybe in getting the discount, it uses some math libraries and does some stuff. So do I end up writing tests against JavaScript's math object and making sure that it knows how to do an add function, right? Maybe I end up writing tests that the Angular code is doing what the Angular code is supposed to do, right? Is routing working when I call the router? Does the routing change? Well, that's the job of the router to know that. I don't need to write tests around that sort of stuff. So again, I should only be testing my code, my unit under test. I shouldn't test, like, if I have a discount calculator, I want to make sure I pass in a mock discount calculator, not pass in the real discount calculator. The third party here, right? I have some router configuration function. And then I call my own getConfig method, right? Well, if I check that the router has a specific route, as long as I pass in the correct configuration to the router's config method, I need to trust that it does its job, right? Here, I'm trying to test the router and its job. It takes in a config and it initializes its routes. If I don't understand how the router works, then that's about documentation, about exploration. But writing unit tests around third-party code, so some kind of a router, writing unit tests that test that the router does its job is not code that I should be writing, is not tests that I should be writing, right? So don't test third-party code and only test one unit at a time. All right, next best practice. Don't use magic numbers, right? We're used to this ideally in our own code that we don't use magic numbers. Here's this example of I'm creating a customer object and I'm passing in 2 random decimals, right? Well, to somebody else coming along, they have no idea what those decimals mean. They probably don't even necessarily know what those fields are, right? And they have to go and inspect the customer object and see what values are being passed in. And these particular values might have really significance, might have a high amount of significance. For example, looking at a better way to look at this, we label, this is just basically name your variables, we label that the discount is going in and the margin is going in, but this is an overly simplistic. For example, maybe 0.8 is our magic margin at which anything over that executes a different branch of code than anything under that, right? So in which case we might call it high margin, or maybe it's our low margin. Anyway, it might be a boundary, and so we can label these boundaries, and now I've made the code more maintainable, or the test more maintainable, because somebody can come along and understand, oh, you're testing the high margin, right? Or maybe the magic discount percentage is 0.25, and so this is another boundary test around a discount percentage. So don't use magic numbers, label your numbers. The next best practice, always, always, always reset your state, right? Generally, tests do this for us. Our testing frameworks do this for us. But there absolutely can be times when we might be, especially with integration tests, certainly with unit tests, it's harder to not allow your state to be reset. But as an example, using the before all function is generally an anti-pattern. It doesn't mean it always is. But generally, you shouldn't run code once for a large suite of tests. You should put that code into the before each. If the code is so slow that you only want to run it once, but you know that it's not manipulating the state, that seems like a case for running it in before all, but that's also a case to consider why in a unit test you have code that's so slow that you only want to run it once, right? Unit tests are supposed to be fast. So it's definitely a code smell to use the before all. Doesn't mean it's a bad idea, doesn't mean it's the wrong idea, but it's certainly something that if you ever use before all, then you should understand what and why you're doing, and 100% make sure that you don't accidentally put state in the before all that doesn't get reset on each test, right? Well, the worst thing in the world is have one test rely on a previous test. So use our before each, we shouldn't use before all in general. So that goes into the next best practice, which is never use test interdependence, right? Again, in this before all, we create a new cart. Then we add an item to the cart in one test, and in another test, we delete that item from the cart, right? So the second test now depends on the first test because we have a brand new cart. If we just ran the second test by itself, it would break because there's no item to delete, right? So this is, again, another anti-pattern. We want our tests to run off of a completely unique state, right? Completely clean state. Never have unit tests rely on previous tests. As a side note, most testing tools and frameworks specifically state that you should not count on tests being run in a certain order. Now, unfortunately, very few of them actually randomize their actual execution order. Generally, they execute them in the order that we author them in the test file. But they tell you very specifically, don't rely on tests being executed in a certain order. So here's a fix for that, right? For the delete item, I should add the item first, then delete the item, and then expect that the item count is correctly. I do that all within the test, right? I don't rely on a previous test to have added the item. All right, so this one is a little bit deeper, making our tests orthogonal, right? So orthogonality is about kind of only intersecting at one point. There's some math behind all of this that I only know a little bit of geometry. I know what squares and parallelograms are beyond that. But when we talk about making our tests orthogonal, we want to make sure that when we have a failure, ideally we only have one test that fails, right? Each piece of functionality, when we break that one piece of functionality, causes one test to fail, ideally. This is really hard to have happen in practice, but we want to optimize and work towards this ideal of a single failure causes one test to fail. Generally, that means that one unit test per meaningful line of logic is how we operate, right? Various branches, they each get their own test. But that way, when we accidentally break something, right? We forget to correctly delete the item out of the cart, then the delete item test is the one that fails. Oftentimes it means that there are other tests for which they assume that the item was deleted. For example, in a previous example here, if we actually broke add item, generally this would cause this test to fail as well. But we call those it's called cascading failures. But really, in that case, still we want the add item test to fail and tell us that this is where the failure is, so that the cascading, once we fix that, the cascading failures go away. So this is hard. This one's hard. It's a pretty idealistic, but it's certainly something to work towards and keep in mind. Another way to state this is one bug equals one failed test. So as an example, in our remove item method, right, we call items.filter, and then we also then tell our HTTP server that we have removed an item, so we delete an item from the server, right? So we have a collection of items. If we're going to remove one of them, and there would be more parameters and such, but if we're going to remove one of them, we have a line of code that removes the item, and we have another line of code that calls off to the server. So what we want is two different tests, because if we break the first line of code, we want that test to fail and told us, you broke the remove item from local collection functionality. If we break somehow the HTTP delete call, then we want a different test to say, you're not calling delete correctly. All right. You're not calling delete correctly. So we want that test to then break and tell us that we have a problem. All right, so that is very related to this best practice, which is one logical assertion per test. So one failed test should be one failing line. Let's look at logical assertions here. Here's an example test. We're going to initialize our cart with 3 items. We're going to call cart.removeItem, and then we're going to expect that the cart's count is 2, right? Then the very next thing we do is expect that we call delete, the delete method that persists, the change to the server, right? At first glance, this looks like a very reasonable test. We're testing that the remove item method works, right? We want to test that the cart's remove item method works correctly, and the cart's remove item method does two things. It removes an item from its internal storage area, and it also tells the server that we deleted an item from the cart, right? So at first glance, this looks like a very reasonable unit test, but this is actually a very poor unit test because we're looking at two different logical things that are going on. One thing is the cart removes from local storage. That's one piece of functionality the cart must implement. Another completely separate piece of functionality the cart must implement is it must persist those changes to the server, right? So if I break either line of code, my test is now broken, and I get this message that the delete is broken, but it doesn't tell me what is broken about delete. Now, in an overly simplified example like this, it doesn't seem like that's that big a deal. You go in and you look and you figure out quickly which line of code is broken, right? But in the real world, it's far more complex. We have methods that do 5, 6, 7 things, and we want to know which of those 5, 6, or 7 things broke. We don't want a test to tell us, hey, this thing is broken, and we go in and we have no idea out of 20 lines of code what is actually broken, right? So we want separate tests. You can call them one test per line, but what we want is to understand that, hey, this piece of code has these logically distinct pieces of functionality. So I want to test each of those logically distinct pieces of functionality and have a test that breaks when I've broken one of those logically distinct pieces of functionality. So related to that is I specifically said one logical assertion, right? Now if I were to test my cart after I remove an item and check that the count is correct, I may not actually have been able to correctly assure myself that the functionality is wrong. What if I accidentally just always delete the last item in the cart when the functionality should be I tell it which item to delete and it deletes the correct item, right? But I accidentally coded up, so I'm always deleting the last item in the cart. So in this case, we need to actually write a few lines of code to make sure that the algorithm is correct. We want to check that the count is now correct. We only have as many items as we expect. We started off with 3, we deleted 1, so we should have 2. We want to make sure that the 2 that are still in the cart are not the object that we wanted to delete, the item we wanted to delete. So in this case, we have 3 physical expectations or assertions, right? But we still have one logical assertion. The logical assertion is I removed the correct item from the cart. And a good sort of litmus test for this is if you're familiar with writing your own custom matchers in Jasmine or assertion statements, like the to-be, that's an assertion statement, writing your own custom. You can write your own custom one. So I could theoretically write a custom assertion for this that would make sense. That basically is collection does not have this item, right? And then I pass in the collection and I pass in the item and it goes through and says, nope, that item is no longer in the collection, right? So I can write a custom matcher that encapsulates these 3 physical expectations or assertions. But I end up ultimately with one logical assertion. I want to know that it removed the item from the cart correctly. And this is subjective, right? In a more complex case, you might vacillate back and forth as to what is a single logical assertion. But that's okay. Not all of programming is objective. But you should definitely optimize towards keeping yourself with one logical assertion. The next best practice, recognize difficult to test code as a code smell. So this goes back to a previous thing that I talked about. This is sort of one of the great theories of unit testing, which is if code is hard to test, then your code is less effective. I like to say that if your code is hard to test, then you're writing garbage, but that may be a little bit too harsh. Difficult to test code as a code smell. So if you're going to test a piece of code and you find that it's difficult to test that code, then you likely should consider that to be a code smell and instead start looking into why it's difficult to test that code. So let's look at some of the reasons why it might be difficult to test code. Is the code tightly coupled, right? So that's by far the first one, and I've been in this situation all the time trying to test legacy code. It's like, man, I cannot extract this unit and just test this unit by itself. It's too tightly tied into a whole bunch of other things, right? It works with with 35 other with other units, and it takes in a bunch of parameters and the way that it operates, I just can't separate it out and write a single unit or write unit tests around that single unit, right? So if it's too tightly coupled to other code, it's difficult to test. If it's too tightly coupled to other code that you can't test it, it's definitely, absolutely less effective code, right? Loosely coupled code is better code, easier to maintain, easier to change. Too many parameters, right? If your constructor takes in 25 parameters, you should absolutely consider that to be a code smell. Well, guess what? Having 25 parameters also makes a piece of code hard to test, right? Because now you have to pass in 25, ideally, mock parameters, right? These are the corresponding collaborators of the code that you're trying to test. If I have to create 25 mock collaborators to test a piece of code, one, that's a lot of setup code I got to write, so that's a real pain in the butt. But that tells me, that's leading me to there's something wrong with my code. And if you have 25 construction parameters, then yeah, you have too many parameters. Another related one to that, it would be invisible collaborators, right? So I'm not injecting all of my collaborators. Maybe somewhere in the code I utilize a global variable. Your tests will tend to discover this, right? Oh, I'm using a global variable. Now, how do I test a global variable or mock a global variable? I have to go through all these hoops to mock a global variable. It's hard, right? The reason it's hard correlates with why your code is bad or less effective. You don't want to be using globals within code. You want to explicitly inject the collaborators to a piece of code so that, one, you can see all the pieces of code, all the collaborators that a piece of code has. It's very explicit to you. Utilizing, instead of constructor injection, utilizing property injection. So you have a property and then you set on that, to that property the value to another class and then those two work together. That's also another way that you create kind of poorly coupled code, right? So usually utilizing constructor injection only and keeping the number of constructors or construction parameters to an ideal minimum helps you write better factored, easier to maintain code. The next one is feature envy. You may or may not have encountered this term before. I think it's a pretty cool term. And that is when one class utilizes the functionality of another class very highly, right? Like you read through the code and it's calling another class every line or every other line, it's calling some method on another class. That's feature envy. That means that this class, that one you have under test, really wants to be the other class, right? It's too tightly coupled in there and they call that feature envy. So that's also very difficult to test because now you're talking to a whole bunch of different methods on another class, and when you create the mock version of that other class, you have to create a mock for a whole bunch of functions on that class. So again, painful to test, leads you to a code smell that you're writing less effective code. Too many lines, right? If you've got 800 lines in a single function that you're trying to test, it's going to be hard to test that. I can guarantee you it will be hard to test that piece of code. Right? So again, the fact that it's difficult to test is, again, universally true. 800 lines in a single function, your function's doing too much. And there are a bunch of more code smells that tests will surface to you as you try to test your code, and you find that it's difficult to test the code. So we can say poorly factored code is difficult to test, and the inverse is true. Difficult to test code is generally poorly factored. This is another interesting best practice is overtesting, right? So specifically, you should test more than you should, which sounds really weird. You should test more than you should. And 100% is a goal, not a reality. And there's a reason for this. I've been in a lot of companies that went through a process where they tried to implement testing. And what they did was they decided, well, let's just be reasonable, right? We're not going to have 100%, and we've got a whole bunch of lines of code that have very little. So let's just shoot for like 10% code coverage, right? Let's just test, and let's only test the easy stuff. Well, the reality, what happens, who could tell me what happens in a scenario like that?
Maybe you have just like one or two devs doing 100% code coverage on their stuff, and no one else does it, so ends up, barely making the marker or something like that.
Right. Yeah. A couple of people take it seriously and everybody else doesn't.
Picking the low-hanging fruit, just testing the easy stuff.
Picking the low-hanging fruit, testing the easy stuff. Yep.
They'll test the happy path only, just the easiest thing to do.
Right. right? Testing just the easiest stuff. Yeah.
Yeah, I thought maybe you might have questions as to what should we be testing with no real concrete answers.
Right. Yeah. Again, not even clarity on what they should be testing. I have found 100% of the time that you will always underhit your goal, right? In all my experience, we've always underhit the goal. If the goal was 10%, we'd end up testing 2% or 5% or something like that, right? And especially the lower the goal is, the easier it is to just not get around to doing it. Well, we only have to test 10% of the code, so we can test it later on, right? The other problem with setting very, very, very low and what you would call reasonable expectations for testing is that then when it comes to the low-hanging fruit, your internal idea of what is the low-hanging fruit gets lower and lower and lower, right? When you say, well, let's just test the low-hanging fruit. Well, it turns out we don't have any low-hanging fruit, right? Because, yeah, this one we could have tested, but it was kind of hard, right? So you start setting your bar low. Your internal bar always ends up lower than what your ideal is. So what happens is you test a lot less than you would have otherwise, and so you test very little. On the other hand, if you overtest, what's great about overtesting is now you start testing things that really you probably shouldn't test, okay? As much as I like to say that difficult to test code means it's poorly factored, the reality is that you're going to encounter some code that's just really difficult to test. It might be mostly configuration-based code. It might be some code that interacts highly with a third party that's really difficult to mock out how the third party works, or the API on the third party is hard. So maybe you write a facade, but now you've got this code in the facade that's hard to test, right? When you overtest and you try to test that and you run into these walls and you bang your head against the wall for a long time, you will discover that one, either the wall was not nearly what should have been broken down, and when you bang your head into it, eventually you break through and you figure out, oh, now I understand how to do this. Or you discover that that actually is a really hard wall, and therefore the stuff that exists in this space, this kind of code, is stuff that is so difficult to test that the value of testing it is extremely low. So that's the kind of code that we can now safely back off from and even delete tests that we've written against that code. But that only happens if you overtest. That only happens if you test stuff you should. I like to say when you're learning a new skill, you should try to learn to do that thing way more than you normally would. You want to learn how to use a hammer? Take away all your other tools and try to build a whole house with a hammer. You will learn very well how to use a hammer in that case, right? And you'll learn the limits of the hammer. You will learn exactly when not to use the hammer and when to use the hammer, and you will be able to use that hammer in places nobody else will know how to use that hammer, but only because you overused it. Only because you went up against the limits of the tool, the technique. When we're talking about unit testing, you went up against the limits of what unit testing is. You will only discover those units if you try to overtest. So ideally setting a goal of 100%. We're going to say, we're going to hit 100%. And when we don't hit 100%, we're going to sit down in a long, boring meeting. We're going to talk about the code that couldn't be covered and why it can't be covered, right? And we're going to make it super painful for ourselves to not hit 100%. And then when you get 80 or 85 or 90 or whatever it ends up you hitting, and you're in those meetings talking about this code, you all come to an agreement that, yeah, we really shouldn't be testing this code, and then we start hitting a better number, right? But we always shoot higher than we want to, and that gets us to a much better place logically. But when you shoot for 20%, you end up hitting only 10%, and you only test the easy to test code that really doesn't deserve a lot of tests anyway, right? It's that middle section that really deserves the test. The hard to test code, because it has the really complex algorithms, we've got to really sit down and think through should we test that. That's the code that, when I say hard to test, I really mean hard to test like hard to think about, hard to write correct tests for and understand what is this code actually doing, right? Or remember that legacy piece that so-and-so wrote and then they left 4 years ago and it still works, but everybody's afraid to touch it, right? That's the code we need to test. And you only encounter that stuff when you overtest. So this is my next really wildly weird best practice, which is you should overtest. This is kind of a related piece to that. Don't use tests to find bugs. This is a little bit of a very nuanced approach. When you're writing an algorithm, oftentimes you think, well, I'm going to write these tests and they're going to find bugs in my algorithm. And sometimes that's true, right? If anybody has ever done the bowling game kata, right? Sometimes that finds bugs in your algorithm. But oftentimes when we write automated tests or unit tests for our code, really all we're doing is fixing in place the existing functionality, right? So we're not so much finding bugs. We might find bugs through the process of, I'm thinking about this code and how to test it, and that identifies in my brain, oh, wait, I didn't think about this case, right? Or I start thinking about edge cases, and I start finding these problems with boundary conditions and such like that. But generally, the tests themselves actually just fix functionality in place, right? What they find later on, they find regression bugs. But generally, bugs more often happen as units interact with each other, as we don't think through what to do in this case, as we don't think through business cases. So end-to-end tests oftentimes are far more effective at finding the actual bugs that affect users, right? Where our unit tests fix things in place. But unit tests cause us to write better code and therefore produce fewer bugs. They help us fix code in place so that we find fewer regression bugs. Or we cause fewer regression bugs as we manipulate and maintain code and add new functionality. We don't break existing functionality, so they keep us from adding bugs, but they're really actually not as ideal for finding bugs. So using tests to find bugs, writing automated tests and writing unit tests will cause you to find bugs, but the tests themselves are not so much the way that we find the bugs. It's the process of writing the tests and the results of having them that cause us to find our bugs. All right, the next best practice, I didn't phrase this, I should have rephrased this correctly. Keep your tests damp. So everybody's cheating by reading, but what does DRY stand for? Don't repeat yourself, right? There's a really good chance that you've heard that. That is probably the #1 dictum of programming, which is don't put duplication in your code. It's the most commonly talked about thing when we're talking about writing good code is remove duplication in our code, right? We don't want the same algorithm to exist in 4 places in our code. We want to write one single function and call that from the 4 places that we do that thing, right? Well, that's our code, the code that we ship, right? We want that to be dry. We want it to be extremely dry. We want to be merciless about how dry that code is. We want to look and see the 2 algorithms that were like 80% similar. We find the pieces that are different. We combine the 2 algorithms that are 80% similar into one, and the pieces that are different, we pass in parameters to handle that sort of thing in that case. Write another algorithm around them that handles the different pieces, whatever. We want to be merciless on that. Tests, on the other hand, we want them to be damp. Okay? We don't want them to be dry, we want them to be damp. And the reason that the word damp is used is because damp is not wet. There's not high levels of duplication, but it's a little wet. So there's a little bit of duplication in our tests. And the reason for this is going to apply to the next one, but we want our tests to be a little bit damp, so we want some minor amounts of duplication in our test. And that doesn't mean we go and find minor amounts, but we accept minor amounts of duplication in our test, right? If we're setting up some code in one test and in the next test we have the same setup code, that's okay. It's completely acceptable to use the same piece of setup code in 2 different tests that are adjacent to each other, or somewhere in the path, right? To have fairly similar lines of code called. So the rules are for this: we should repeat ourselves if necessary to make it easier to read, and we should minimize our logic out of our tests when we can. All right. So why this is in this next best practice, which is to tell the story. And this is like kind of my favorite best practice to talk about, is telling the story. And I think this is where you kind of start hitting the Zen level of tests, right? So a test should be a complete story. We'll read the bullet points. A complete story all within the it. You shouldn't need to look around much to understand the test. And so we put our less interesting setup in the before each. We keep our critical setup within the it. We include all of the act and assert parts in the it clause. Now, we're going to dig into this and talk about this. Tests are a story. Who here likes Mulan, has seen Mulan anyway? Who here likes Mulan? I love Mulan. It's like my favorite Disney story, right? I just love the hero's journey that she goes on. It makes me cry every time I watch it. Anyway, when we see any story, but let's talk specifically about Mulan, it picks up at a very specific point in the story, right? We didn't see Mulan get born. We didn't see who her grandmother married. We have no idea who her grandma married. We don't know how much they paid for their house when they bought their house. We don't know how big their land is. Why do we not know these things? Because they don't matter to the story. They matter to Mulan. She knows who her grandfather is. If the cartoon person was actually a real person. She cares about her grandfather. And her ancestors were like a big part of her life, right? She cares about that. She cares about how big her house is, right? She has to maintain it, how big her land is. Those are all things that matter to Mulan. But us as the viewer, those things don't matter to us. So if they put those things into the story, it makes for a bad story, right? What makes Mulan a great movie, and if you disagree with me, then we can fight about it afterwards. What makes Mulan a great story and a great movie is because only the right parts are shown. In the middle of it, the training montage, you know, they really talk about that because that shows Mulan's growth. It's very important to understand the change that Mulan goes under when she goes in and they sing those fantastic songs and Donny Osmond gets up there and takes over for whoever the actor was that plays Chang and sings, right? Those parts are all very important. But we don't see every aspect of her life while she was in training camp, right? There's plenty of parts that were taken out. We only, because as the viewers, we care about those certain things. And there's an important part. If we might say to ourselves, oh, I really care about how big her house is. I'd love to see, you know, in the movie them talk about how much they paid and how much land they have and how they grow their stuff. Even if you tell yourself that, the reality is when you watch the movie, you will find yourself less entertained and less likely to enjoy the movie, right? A test is the same way. A test is a story, and it's very important that the test tells the story all within the it. Right? All within that it function should be the complete story of the test. And for us, that mostly comes down to a few points that are mentioned here. Right? We have what is the interesting setup, and we have what is the less interesting setup. Okay, we want the interesting setup to stay inside of the it. The critical setup must be inside of the it. We want the less interesting setup, we want to push that up to the before each. We want the act to be inside of the it. As much as we can, there are a few cases, for example, when we're just testing like the initial state of an object. Sometimes it's hard to put that inside of the it for various reasons. But we want the act to be inside of our it, and certainly all of our asserts. We should have no asserts somewhere else. All the asserts should be inside the it, right? There should not be any after all that asserts something general in every case, right? We want the asserts inside of the it. Let's look at this a little bit more in depth here. So here's an overly dry test, and this is such a ridiculously simple example, but it illustrates the point here. This is Angular. We're testing the initted state of a component, right? So because we're doing manual tests, we have to manually call NGOnInit. You see that up there in the top in bold. And in our before each, we create the component, and obviously there's no, this create component is, right? We would construct our component somehow. We manually call NGOnInit. And then we come down here and we have a first test. Hey, it should set the hero. So we check that the component's hero has been defined. And then in a different test, we check that this hero ID has been set, right? Again, we're testing two different pieces of state, so we want two different tests. And so we also expect that the hero ID is a certain value, right? Well, what we're missing here is the important part of this story, which is the NGOnInit. This is a better done test, right? Look inside of each of those its and before each. The before each no longer has the NGOnInit. Instead, it is called in each test. Why do we call the NGOnInit? Why not put it up in the before each? Because it's a critical piece of each of these tests. We need to understand that the NGOnInit was called. This isn't just an initialized component. And we need to understand what has happened to the component to bring it to this state, right? The init was called. Did we add a hero? Did it have a default hero? Whatever. We want to understand those things so that when we test the hero property and the ID property, we understand what they are. And when one of these pieces of functionality breaks, we generally don't have to go back and look up at the before each. Now, in this case, with tests that are 2 lines of code and a before each that's 1 line of code, this doesn't seem like a very important principle. But in the real world, we'll have 25 tests, and the one that's broken is the 20th test, and we're 4 screen heights down looking at that test, and the before each is way up there. And yes, with some modern IDEs, we can do a split and bring the before each into focus in the top half and our it in the bottom half so we can look at the 2, right? But now I have broken the story. I'm no longer telling the story in the it. If I tell the story in the it, all the critical and important setup is done. All that arrange that really matters to the test is done inside the it function, and the unimportant stuff is done outside. I know that the component has to be constructed, right? Because it exists there, I can assume that. Does the component itself take in some really critical construction parameters? If that's the case, I'd move the construction down into the it. But if the constructor doesn't take any critical parameters that affect this test, then I can safely move that up to the before each. And again, it's not just are they critical, it's are they critical to this test, right? Is there some necessary preconditions we have to set up that are so unimportant to this test, but they just have to be there in order for the code to work? We move those to the before each. But what is our initial state? How do we derive at our initial state so that this test works? We want that at the beginning of the it. We want that in the it. And then whatever our state changes, we want that in the it. And this is so overly simplified because we're only using the ng on init. We're just using the init function. But if we were testing, again, like remove cart, we want to know what the cart was initialized to. We want to know when we removed it. We want to see that, how we removed it. And we want to know what assertions we make to know that the cart is now correct in its correct state. So again, a test should tell a story. You need to tell the story with the test. Be sure that all your critical setup is inside of the it. All your state changes and all of your assertions exist inside of the it. So that brings us to the conclusion. In sum, we want to use the arrange, act, assert. There's actually, has anybody here ever done any testing at the framework that supports true mocks, where you set up behavior expectations as you create your mocks? Has anybody ever done that with C# has some libraries like that, Java has some libraries like that. Okay, so there are, what's that? Spock? Yeah, so there are libraries that support this. Sign-on.js, one of the most popular mocking libraries, has support for this. In that case, you set your assert. You have to do your asserts first, and then you do your act. Then you do your range, and then you act. And the asserts almost become part of the arrange. I hate those for a very important reason, because you put the assertions in a really weird spot in the test. It's not initial state, change, check the resulting state. So I highly recommend that when you can, you don't use actual true mocks, right? There's these pedantic academic definitions for, we call them mocks, but what we mean when we say mocks generally is what's called actually test doubles. That's the big umbrella term for all kinds of mocking objects. And underneath that, mocks are a very specific thing, stubs are a very specific thing, dummy objects are a very specific thing, right? We commonly use the term mocks to mean mostly stubs and dummy objects, but mocks themselves in the very academic definition are this very specific type of thing, and I generally recommend people not to use actual true mocks. Instead, most libraries, you can pretty much do with stubs and dummy objects, stubs and spies, everything that you can do with mocks, generally. So, arrange, act, assert. Next, we want to include our tests in our CI, make sure that we're always running our tests when we check in. We want to make sure we only test our unit. Don't accidentally include some third-party code or some other units. Don't test our frameworks or other third-party code. Don't use magic numbers, right? Name all of our variables, especially when we're talking about meaningful numbers, right? Always reset state, like going back, obviously it would be kind of silly if testing an add method to create a variable for 2, right? It's okay to pass in the number 2 in that case. But for numbers that actually have meaning, name those numbers. Always reset our state, right? We always operate each unit test with a clean state. Never use test interdependence, never rely on a previous test being run before a given test is run. Always better to remove that code or duplicate that code in the test. Again, we make our tests stamp, not dry. Make our tests orthogonal. Try to make our tests such that any given failing line causes only one failing test. That one is probably the hardest of all of them to actually make happen. Only one logical assert. Never combine multiple tests into the same test, same it function, right? Even though, yes, I've started with state A and I changed to state B, these 3 things happen, so I'm going to check that all 3 things happened. No, do not test that all 3 things happened. Write 3 separate tests. Recognize difficult to test code as a code smell, right? That theory that hard to test code is less effective code. Overtest. Do more testing than we think we want to do. Make our tests stamp. We accept certain amounts of duplication inside of our tests. And finally, in my opinion, the most important one is to tell the story in the test. Make sure that the complete story of what the test is there inside of the it function. And that's it. Those are the best practices for unit testing. Thanks very much.
Any questions for Joe before we close up for the night?
What are your feelings on TDD versus BDD?
Let me make sure that you and I are talking about the same thing when we say BDD. When you say BDD, you mean more like, right, like an end-to-end test first,
Yeah, like behaviors.
right? And then write unit tests inside of that. And as the unit tests get complete, we slowly fill up until eventually we have some end-to-end or potentially functional test that now passes.
Essentially, yes.
I love that. I think that's great. I personally have almost never practiced it. Right? I've tried it a few times, but at least in my history, it's usually we're like a super heavy unit testing shop or a super heavy end-to-end testing shop. But so I don't have enough direct experience with it to say that it's great. But everything that I've done in my career has indicated that it's just a better form of TDD, really, because now you're talking about, hey, the actual user is experiencing this functionality a certain way. I think if you do practice BDD, you got to be pretty accepting of the fact that your outer test will oftentimes change as you refactor how the user experience works, but that's perfectly acceptable.
Question. The it with one logical assertion. I know you kind of griped on that, but you talk about this whole damp theory, but what if it's like the same object has some, you did one thing and it caused three things? I mean, you still want to put them in different damp tests, I guess, if they're on different lines.
Yeah, I know. One, it can either seem really weird when you first do it, right? Or two, it might just seem really inefficient, right? It's like, well, most of the time I do this, but I got this one where I'm doing a whole bunch of stuff, and so it's super inefficient to put it into separate tests. But the tests, the name of the test documents the functionality of the code, right? It's not comments that's documenting the functionality, it's that name of that test, right? And that name of that test needs to be focused on what's actually going on. And so we're talking about, you know, I change the cart and it causes three different things, then now my test becomes remove item works, right? And that's not a good test. Remove item removes the item from the internal storage mechanism. That's a good name for a test. But that doesn't tell me that when that test breaks, it doesn't tell me that what really actually happened was when I called persist to the server, that's the thing that was no longer working, right? When I have a separate test that says persists removal of cart items to the server, then that test breaks because I broke the .save call. That tells me what goes on, and it documents what the code is supposed to do. Those two tests now document both pieces of functionality. But if I try to put that into one test, I end up with these names that are either something like removes it from internal storage and does this, and does this, and does this, and does this. And that's not a good pattern to follow. And unit tests, again, tend to be so fast that writing 3 or 4 tests when you can combine them into one is rarely much of a problem. And you usually, you know, if you write a huge test suite, 5,000, 10,000 line tests such that it does take 30 or 60 or 4 minutes, 30 seconds, 60 seconds, 4 minutes to run, then you tend to just run, you know, only run a specific suite or piece of the suite at a time anyway, so it's still going fast. Then it's fine, and then you turn it all on for a CI, and you just let the CI just run for 3, 4, 5 minutes. Acceptable, but yeah, in my opinion, write that as 3 separate tests and document it out separately. Any other questions?
All right. Well, everybody, let's give it up for Joe Eames. Thanks so much, Joe, for coming. Awesome. We're welcome to hang out here a little bit. We're all going to kind of loiter around a little bit. Chance to, if you want to come up and ask Joe a question, you can do that. If you think of something, chance to hang out, kind of network, and find out what's going on in each of our lives. So just want to thank everybody for coming, and hopefully we'll see you on February 19th downtown.
Can we litter and loiter?
Litter and loiter?
Littering is not good.
Yeah, sure. All right. Thanks, everybody. Let's see here.